And welcome to Chapter 2, The Science and Methods of Environmental Health. And so this is a really good chapter, just kind of breaking down all the things that go into environmental health. And it's a pretty long lecture. It's a pretty long chapter as well. So take your time with it because it is kind of that foundational building block as you move forward into the science of environmental health and really what's being talked about with a lot of these things. So when we get started, there's a lot of key definitions. So you got fate, and so kind of what happens to a chemical or physical transformation of those contaminants, like where is it going, the fate of something, and then how does it move there, is that transport of it. And so the fate is affected by a lot of things when it comes to our physical and chemical properties of a particular contaminant when it comes to environmental health. And so think of contaminant being a variety of different things. Could be smoke, could be with water, could be radiation. There are lots of different things that could be considered a kind of a hazard, as if you will, or a contaminant. And so it's validity of it. So how volatile is that thing? Does it easily break apart? Sometimes referred to as a half-life. Is it unstable in certain areas? Does it react with things? Is it soluble in water? Does it dissolve in water? Or is it attracted to fat? Each one of these things is going to affect the fate of it at the end of the day and where it winds up, and then how it affects someone's health. So when you look at this, you're looking at these physical chemical properties. Things that tend to like fat will end up in living tissues. Could be fish, could be us when we eat those fish. If it likes to dissolve in water, we're likely to see it in that water. And that could even go into the air, depending on if it can stay in those water particles as they become a gas. And so that can also lead them to coming in contact with the soil, and how much validity they have to change forms is also going to depend on where they end up and how far they can spread at the end of the day. And so you have things when it comes to these building up of this lipophilic tendency. So concentrations can move. So maybe something can move through the fat tissue over time. Sometimes we have things like bioaccumulation, so they build up in the fat. And so the more you ingest over your lifespan, the higher that concentration is and could have more dire effects. And then you've also got that biomagnification as well. As it goes, biomagnification is basically saying each step up a food chain as you eat something will continue to concentrate the particular contaminant, and leaving as humans usually on the top of that food chain, more likely to suffer from health hazards from that contaminant. And so this again is kind of looking at the chemical properties, physical, chemical, and how the fact that things that are smaller and typically have a lower molecular weight or are more volatile and more water soluble, and things that have a higher molecular weight tend to be not as easily dissolved in water, don't move as easily. Just think kind of big and small. And so you do keep those things in mind. And then we also have to think about things like how the atmosphere and how these things are in the atmosphere and what level do they tend to travel to in our atmosphere. We have different layers of our atmosphere, and so if it stays close to the ground, that could affect us directly, but there are things that travel higher up into the troposphere that can play a bigger role in. You can look at maybe global warming as something, the degradation of the atmosphere, or just the way it'll interact with things up there, such as ozone, which we don't have here on the ground very much, O3, but ozone is very high. As you go up in the atmosphere, you find more of it. And so if a certain contaminant acts with ozone readily, if it gets up there, it could cause a bigger issue, and these things have to be considered. And our stratosphere is exactly what this says. We have much more of that O3. And so along with that, the global wind patterns are here. You can kind of see what we see is this global air circulation that occurs in different layers. But that's going to be different depending on what level of the atmosphere we're in, whether we're ground level or higher up in the stratosphere, things like that, and how it's carried. And those are going to be needed to predict the way things go. So if a nuclear radiation, nuclear bombs to go off, and radiation gets into the upper atmosphere, well, we need to know kind of where it's going to carry to know what people will be affected as that moves forward. So temperature can make a difference. Everything that we experience in a weather basis will all make a difference with environmental health. Our water and where we get our water and how that water is developed is going to make a difference. And so you have to keep in mind basically the water cycle. And the water cycle having to do with condensation and evaporation, and the fact that our water, when it rains and goes into our lakes and rivers, it also goes underground to aquifers that we get water from and springs. And that could have come from the ocean. It could have come from another part of the world. And so you're quickly starting to see how one thing in a localized area, if it gets into the air or to the water supply and continues into water vapor, can start having a greater effect across many, basically a global effect as it deposits that water and those chemicals in other places. And so again, it's going to matter how that water is developed and whether it's on the surface or underground, and just how easily that's transported. So if you think about water underground and like an aquifer, it's going to take a long time for that source to become contaminated. But once that source is contaminated, it's going to be much harder to remove that contaminant because it's not as easily interacting with the environment around it. It's not able to evaporate and move those chemicals out. It's kind of that ending point if it is in the water. And so again, your book kind of just continues to talk about that, and then it moves into the toxicology, the science of poison. So that's really what you're looking at with toxicology, things that poison us. Some things that we have may not be toxic in small levels, but as they build up over time could be. And this could be through inhalation, ingestion, or even through the skin. We can actually absorb things through the skin when it comes to it. And so the amount of exposure and the dose that we receive matters. So the exposure is how much time you were kind of in contact with that, and then the dose would be how much of it was there. And so you can kind of look at this as the dose being, think about medication. How, let's say you're taking Tylenol, did you take 1 or 2, right? 2 is going to have a bigger effect. That's a larger dose than 1. And your exposure is thinking about how long were you exposed to that. So typically if you take a medication, it would be the time it takes for it to process through your body, maybe a few hours. But if something you consumed slowed that digestion process down, you may be exposed to that medication for a longer period of time, and that could have different effects. And this applies with all kind of contaminants or anything we interact with, especially when it relates to toxins. And so things that are affecting our toxology would be toxokinetics, which is how readily do we absorb it, or how is it absorbed, the distribution across our body. Are we able to basically consume that product, metabolite, so get rid of that out of our body? Do we store it? Where do we store it? How much of it do we store? And then can we even excrete it? And so these are all the different parts that are being looked at. And so you can start seeing in this chart where these things apply and how these are related, about absorption getting in, and storage and excretion, and all of those are eventually going to lead to those possible health effects that may be seen. And so it then talks about carcinogens, which are basically cancer-causing agents, and how those may interact with our DNA and cause cancers over time. And our genes play a huge role in this. And so it all goes back to what we call a dose-response relationship, which is where how much of a dose do we need to get a certain response. So the more of a dose of something, we get usually a greater response, but is that linear? So if I double the amount of the dose, do I get a double in the response? Some things are not so. We can be safe for a high dose of particular substances, and then if we cross that line, the effects that occur to our body may be tremendous and cause huge effects. And so we really have to look at those as you're going through that. And so you can see here this dose showing kind of these relationships, dose-response relationships, how something can be more potent or less potent, and how those doses can occur. So with B here, you can see B, there's that one-to-one relationship. But with A, what we see is that the dose, you have a certain dose where you get no response, and then eventually there's enough that builds up in your body and you start showing that response. And so a lot of different ways to look at that. And again, looking at these curves where no effect, we have effect happening, and then we get to a certain point where we've basically maxed out the dose and we see no more response to that, and how that curve can shift over time. So as you're doing that, you'll be reading about toxicology testing and how those can be tested for in different ways. A lot of times this is done in animal testing. It's not done in humans on purpose. Sometimes we see this toxicity testing done or reported in humans maybe as an observation, unless it's an actual medication. But in rodents, they will give them certain chemicals that we know are harmful to figure out what kind of dose may humans be able to withstand, so we know what to look for. And so that kind of gets us through a chunk of your chapter. You'll want to continue to read on and look at the different things going in there, to the different ways to look at the science behind and the environment and environmental health. But this does a good place for us to stop, and you can continue to read on and just let me know if you guys have any questions.